As we converse, the night sky we have long known is undergoing a significant transformation, one that may render it unfamiliar in a matter of decades, or perhaps even years. Astronomers from across the globe have sounded the alarm, with renowned experts like Neil deGrasse Tyson recently confirming unsettling news about Polaris, the North Star, which holds a special place in our nocturnal tapestry. Until now, Polaris has remained a steadfast presence, a celestial constant relied upon by stargazers, sailors, and astronomers alike. Yet this status quo may soon be in jeopardy, potentially altering not only our nighttime vista, but also the way we measure and understand the cosmos. Join us as we unveil the gravity of this impending change and delve into the story of Polaris as it approaches its inevitable end. Polaris, known as the North Star or Pole Star, has long served as a guiding light in the firmament, cherished by generations of skywatchers and navigators. However, its enduring presence in the heavens faces a sudden and unforeseen threat. In a recent research paper presented by the esteemed Royal Astronomical Society in September 2023, uncertainty now clouds the fate of this celestial luminary. Polaris teeters on the brink of a cataclysmic explosion, poised to vanish from the night sky forever. Before we explore the repercussions of this revelation, let us first acquaint ourselves with this star. Polaris occupies a unique position in our celestial canopy due to its close proximity to the celestial North Pole. It appears nearly motionless in the northern sky, situated almost directly above the Earth's North Pole. Nestled within the constellation Ursa Minor, also known as the Little Dipper, Polaris is a moderately bright star, surpassing our Sun in both luminosity and radius. Shining with a yellow-white brilliance, it possesses a radius roughly 40 times that of our own Sun. Often mistaken for a solitary star, Polaris is actually part of a complex triple star system. Its primary stars, Polaris AA and Polaris AB, appear as a single point of light to the naked eye, while a third companion, Polaris B, orbits this binary pair. Interactions among these celestial actors result in gravitational forces that shape their orbits and influence their behaviors, leading to irregular variations in brightness and pulsation patterns when disturbances occur in their interactions. However, the precise details and complexities of these interactions remain shrouded in mystery. Polaris resides at a considerable distance of approximately 323 light-years away, meaning the light we currently behold from it harkens back to its state 323 years in the past. Consequently, if Polaris were to erupt in a brilliant display today, our awareness of this cosmic spectacle would remain elusive until the passage of 323 years. By the time this celestial phenomenon graces our terrestrial vantage point, it shall have already unfolded over 3 centuries in the annals of history. The forecasts crafted by the scientific community are founded upon empirical evidence discernible in the present moment, implying that Polaris may have already undergone its celestial transformation, with the light from this event yet to reach our observant eyes. Throughout history, the North Star has woven a tapestry of significance across diverse civilizations, bestowing upon humanity substantial cultural, navigational, and symbolic worth. Its unwavering presence and steadfast location proximate to the celestial North Pole have rendered it an invaluable navigational ally for seafarers and wanderers of yore. It has stood as a guiding beacon, enabling mariners to find their bearings and traverse vast oceans and continents. Its alignment with Earth's axis has bestowed upon it the status of a reliable point of reference for ascertaining direction, particularly within the confines of the Northern Hemisphere. In various cultures, Polaris has symbolized constancy and resoluteness, an unwavering presence amidst the celestial ballet of the night sky. Within myths and folklore, it has often embodied guidance, stability, or even a celestial anchor. Furthermore, Polaris's steadfast station in the nocturnal heavens has proven paramount to astronomers, serving as a steadfast marker for observing other celestial entities and aiding in the meticulous examination of the heavens' movements and patterns. As a Cepheid variable star, Polaris exhibits regular fluctuations in its luminosity, furnishing us with invaluable insights into the nature of variable stars and fundamental stellar properties. However, as of late, the star has deviated from its expected behavior, presenting unsettling irregularity in its pulsation cycle that has left astronomers puzzled. Instead of adhering to the anticipated pulsation pattern, Polaris has embarked on a capricious and unpredictable journey of dimming and brightening. Concerns have arisen within the scientific community, suggesting that this celestial anomaly might be signaling the star's impending demise. Such behavior aligns with the typical tendencies observed in stars as they approach the end of their life cycles. The gradual elongation of Polaris's pulsation period, which was once reliably stable, can be attributed to interactions within the star system that appears as a singular entity to our eyes. From our vantage point, we have observed a yearly increase in the pulsation duration of about 4.5 seconds. While this increment may seem inconsequential, it carries significant implications. Some astronomers have cautiously theorized that the gravitational interplay among the Polaris stars could be responsible for inducing fluctuations in Polaris's atmospheric conditions, thereby influencing its pulsation patterns. However, there are those who firmly believe that the star is on the verge of a catastrophic explosion, drawing parallels to the enigmatic behavior of Betelgeuse, another prominent star in the Orion constellation, which has exhibited perplexing irregularities in its luminosity. Numerous experts have sounded the alarm regarding the inevitable fate of Polaris. The similarities in the fluctuations observed in brightness and patterns between Polaris and Betelgeuse have raised intriguing questions about their behavior. Cepheid stars, as they near the twilight of their existence, often display such patterns before reaching the culmination of their cosmic journey. While NASA has closely monitored Betelgeuse's peculiar behavior, expressing heightened concern about the possibility of a supernova, a similar level of scrutiny has yet to be officially declared for Polaris. The star's appearance might undergo a remarkable transformation, transitioning into a radiant point of light or a transient celestial object, perhaps adorned with vivid hues before gradually fading from view. This visual extravaganza could temporarily disrupt our familiar perception of the constellations like the Big Dipper or Ursa Minor, for Polaris currently serves as the North Star and is integral to these stellar patterns. As for the safety of our planet, there is no need for concern. Given Polaris's considerable mass and distance from Earth, our world would likely remain unaffected even in the event of a supernova. While a Polaris supernova might not deliver as spectacular a display as Betelgeuse's potential explosion, it could still be observable to the naked eye for an extended duration, outshining neighboring stars. Astronomers and observatories worldwide would undoubtedly take note of this celestial event, piquing the curiosity of the scientific community and skywatchers alike. Nevertheless, the specific impact on Earth's atmosphere or immediate surroundings would be less significant compared to a supernova occurring at a closer cosmic proximity. Now, let's address the fate of Polaris on the precipice of a potential supernova event. It's critical to clarify that while massive stars often culminate their existence with a supernova, this is highly unlikely for Polaris. Typically, when a massive star undergoes a supernova, it experiences a colossal internal explosion, marking the dramatic final act in the star's life cycle. This event results in the dispersal of heavy elements and may lead to the formation of neutron stars or black holes. This process entails a complete core collapse in a high-mass star, usually around 8 times the mass of our Sun. As the star depletes its nuclear fuel, it can no longer withstand its gravitational forces, causing the core to crumble. This collapse triggers a powerful shockwave that propagates outward, leading to a spectacular and violent star explosion. Supernovae are broadly categorized into 2 main types based on their specific characteristics. Type 2 supernovae manifest in massive stars with complex internal structures, where the core's collapse results in the explosive expulsion of outer layers, producing a luminous burst of energy visible over vast cosmic distances. In contrast, the more elusive Type 1 supernova occurs in binary star systems, often involving white dwarfs in close proximity to a massive companion star. In such systems, the white dwarf can accumulate matter from its companion, eventually reaching a critical mass that leads to a cataclysmic explosion. This process, too, heralds the dramatic end of the star's life cycle, but unfolds in a different manner than Type II supernovae. The consensus among astronomers suggests that Polaris, despite its Cepheid classification, may not possess the requisite mass to undergo a supernova explosion. Instead, it may ultimately transform into a white dwarf. This slower evolutionary phase could unfold over the span of several billion years, leading to the gradual cessation of energy output until it fades into obscurity, becoming merely a relic of its former brilliance. For those eager to glimpse the future of Polaris, the next few thousand years may hold answers. Astronomers will continue to monitor its behavior, unraveling the mysteries shrouded in its irregular pulsations. As technology advances, the chance to observe Polaris may yield insights into the life cycle of stars, deepening our understanding of stellar evolution. Until then, we can only gaze at the sky, contemplating the potential changes that lie ahead. The disappearance of Polaris, while likely far in the future, raises essential questions about our cosmic connection and the inevitability of change in the universe. In conclusion, while Polaris remains a guiding star in our sky today, the future holds uncertainties. Whether it undergoes a supernova explosion or transitions to a white dwarf, the tale of Polaris is a reminder of the dynamic nature of the cosmos. Our understanding of the universe will continue to evolve, revealing the intricate connections that bind us to the stars above.